Okay, now that we're done simplifying radicals, let's deal with some expressions and some operations with those radicals. And it's going to look a lot more confusing than it really is. It's really the same thing as combining like terms. So for example, if I have a 2x and a 7x, they combine to be a 9x, right? Because they both have an x. The exact same thing works with radicals. And if I take a look at this example here, I have 7 plus 2 in parentheses. And that's being multiplied by the square root of 5. So if I simplify that, add my 7 plus 2, it's 9 times the square root of 5. Well, if I look at it over here on the right side, here's where my operation comes in. I have the same base. I have a square root of 5. So I have 7 roots of 5, and I have 2 roots of 5 for a total of 9 roots of 5. 9 root 5. 9 times the square root of 5. And I get the exact same thing, right? So as long as they have a like radical, we can combine them. Let's take a look at a few examples here. So we look at all three of these terms. They all have a square root of 5. So they're all like terms. We can combine those two. So all we're doing is combining their coefficients in front. So I'm going to take a 6 plus a 2 and subtract a 5. So 6 plus 2 gives me 8, minus the 5 for 3. And I just keep my square root of 5. Just as if it were an x or a y or anything like that. It's just a like term. So I'm left with 3 roots of 5. And I should check to see if it's fully simplified, which basically means, are there any perfect square factors of 5? Nope, so it's simplified. 3 times the square root of 5. Good to go. Let's look at this next one. Okay, now we're dealing with a couple different terms here. I have terms with a root 2 in it. So I can combine those two. All we're looking at their coefficients. So I have a 7 and a negative 6. So 7 minus 6 gives me a 1. So really I have 1 root of 2 left. I don't really have to write that 1. So I'm going to erase that. Because 1 times the square root of 2 is just the square root of 2. And then I also have 8 roots of 11 and negative 4 root 11. So we want to combine their coefficients because they both have the square root of 11. So 8 minus 4 gives me positive 4 and keep my square root. And since these have different bases, I have a square root of 2 and a square root of 11, I can't combine those. So we're done. Square root of 2 plus 4 times the square root of 11. So it's basically just combining like terms, except in this case, instead of having variables that we look for like radicals. We look for like radicals. Let's look at something else here. If I look at these three terms, they have different radicals, right? 27, 12, and 75. So your initial thought is, hey, I can't combine those. But guess what? We can simplify them, can't we? Just like we did yesterday. So if I look at 27, does it have any perfect square factors? It does, right? 9. 9 times 3. So I can simplify that. I'm going to go ahead and do that one first. I'll write it out like you should. Some of you are able to skip this step, but that's okay. So I can break that up to the square root of 9 and square root of 3. And square root of 9 is really 3. And 6 times 3 is 18. So I have 18 times the square root of 3. That's what that one simplifies into. Go to the next one. 12. It's got a perfect square factor of 4. So 4 times 3. I'm going to do this one a little quicker. The square root of 4 is 2. And 8 times 2 is 16. So I got 16 root 3. I'm going to write that down here. So positive 16 times the square root of 3. I did the shortcut way on that one. I'll do this one the long way. 75, the biggest perfect square factor would be 25. So 25 times 3. And I'll write this one out. So I got 2 times the square root of 25 times the square root of 3. And the square root of 25 is 5. So 2 times 5 is 10. So plus 10. And sometimes the square root of 3. Well, now if I look, now I have all like terms, all like radicals. I got all root 3's. So I can combine their coefficients. So 18 plus 16 plus 10 gives me 44. So I got 44 root 3s. 44 root 3s. And I am simplifying. 44 times the square root of 3. Okay, so you actually have to simplify everything, right? Make sure you simplify everything. So don't just look and say, hey, these aren't alike. Because if they simplify and they're alike, then we can combine them. Okay, so use the rules that we used yesterday, and now extend on it from what we got today. With multiplying, we're multiplying property we learned a long time ago. Multiplying is commutative, right? So it doesn't matter what order I multiply. This just says 2 times the square root of 3 times 4 times the square root of 6. I know it looks like 2 root 3 times 4 root 6, but it's all just multiplication. So multiply in any order you want, which means I'm going to multiply 2 times 4 first, since they're on the outside of the radicals, which is 8. And then I'll multiply what's inside the radicals. Square root of 3 times the square root of 6, and we learned about that property before. I can multiply those inside the radical together for square root of 18. Now, don't think you're done. You always have to look to see if you can find perfect square factors of what's inside the radical, what your radicand is. And if I look at 18, 9 is a perfect square factor. So I can break this into 9 times 2. So I got 8 times the square root of 9 times the square root of 2. And the square root of 9 is 3. So 8 times 3 is 24. And I still have my square root of 2. Okay, so you always have to look to simplify the radicand. Okay, if they have perfect square factors, you have to simplify. And remember, multiplying, you can just multiply anything, right? So do the stuff outside the radical and then the stuff inside the radical. Well, here I have 4 times the square root of 2 times that sum, right? 3 root 2 plus 2 root 6. This is just our distributive property, isn't it? So I would take 4 root 2 times 3 root 2. Well, just like before, multiply the numbers on the outside. So 4 times 3, which is 12. I'll do that 4 times 3. And then take square root of 2 times the square root of 2, which is the square root of 4. But I know that's just 2, isn't it? That's really just 2. So 12 times 2 is 24. So there's that first one. And then let's also take 4 times the square root of 2 times 2 times the square root of 6. So multiply the numbers on the outside of the radical. So 4 times 2, which is 8. And 2 times 6, what's inside, which is the square root of 12. And if I look, some people are going to think, well, I'm done. But remember, always look. If you have a square root, does it have perfect square factors? Well, 12 does. 4 times 3. So some of these take a little bit of work. So really I have 8 times the square root of 4 times the square root of 3. And the square root of 4 is really 2. So 8 times 2 is 16. So I really have 16 times the square root of 3 there. And let's bring down my 24. Okay. So sometimes you're going to simplify more than others. Okay, but you just always have to look for it. Does that radicand have perfect square factors? Okay. And otherwise we're just applying old properties, right? Multiplying, you can multiply anything, distributive property, so on and so forth. Okay, just make sure it's all the way simplified. And lastly, let's apply to a little bit of geometry. Talking about the area of a rectangle. Well, area of a rectangle is length times width. And here's my length, here's my width. So let's multiply those two. So 5 root 3 plus 7 root 5 times the width, 4 root 6 minus 2 root 10. Here we go with got our FOIL method, right? So I'm going to start with the first one. 5 times 4 root 6, or 5 root 3 times 4 root 6. I'm going to bring this way over here. So 5 times 4 is 20. Then multiply what's under the radical, square root of 18. Okay, go to the next one. 5 times negative 2 is negative 10. Square root of 3 times the square root of 10 is square root of 30. Okay, good. Now the insides, 7 times 4 is 28. And square root of 5 times the square root of 6 is the square root of 30. Okay, and lastly, 7 times negative 2 is negative 14. And root 5 times root 10 is square root of 50. Alright. So maybe combine like terms. I can combine these middle two terms here. We'll go ahead and do that. So I got 20 times the square root of 18 plus 18 times the square root of 30, right? Just negative 10 plus 28. And then bring my minus 14 times the square root of 50 down. Well, remember, don't think you're ever done. See if you can simplify what's inside the radical. Perfect square factors. So I look at 18 here. I got 9 times 2, don't I? And the square root of 9 is 3. So 20 times 3 is 60. So 60 times the square root of 2. Looking at 30. Are there any perfect square factors at 30? Let's see. 4 doesn't go into it. 9 doesn't go into it. 16 doesn't go into it. So we're good. This one, there are no perfect square factors, so I leave it as 18 times the square root of 30. And 50. Well, 25 times 2. And the square root of 25 is 5. So 14 times 5 is 70. So minus 70 times the square root of 2. Oh boy, I still got square roots of 2 now. So some of these might take a while. So let's combine our square roots of 2. So 60 root 2 minus 70 root 2 leaves me with negative 10 square roots of 2. And bring down my 18 times the square root of 30. And there we're done. So negative 10 times the square root of 2 plus 18 times the square root of 30. And I guess if you want to label, you could say units squared since it's area, but I'm not too concerned about that. Okay, so your FOIL, right, your distributive property, start simplifying, right? Combine like terms, find perfect square factors of what's inside the radical, and just keep simplifying. It might take way more steps than you ever could expect. Okay? Some might go really quick, some might take a while. But you just got to always look to see if you can simplify. All right, there you go. You got about 11 problems. Good luck. Deuces.